This video is going to talk about some of the more technical aspects of our thermostats, and particularly how they interface into the various networks for remote and local management. The thermostats that we have are Proliphix, and this is a fairly new company that has come up with a product that I think is fairly innovative, and that it's kind of a bridge between a home programmable thermostat and the more expensive building management type systems that are, typically many thousands of dollars, that allow you to manage the energy in the building remotely and through some type of computer interface. This is kind of the bridge between those, and what's nice about them is that they are completely independent. You don't have to have a computer. They don't have reliance on the network. They're fully functional on their own, but then they have an interface that goes into our computer system through an Ethernet cable, and that allows you to have that interface for managing them independent of the actual unit themselves. So what they kind of look like is right here. They come in different models. We have the NT120, and we actually also have one NT130, and we'll get to that in a second. And there's digital thermostats that hang on the wall. They have a regular thermostat cable going back to the furnace, just like any other home thermostat would have, or a commercial thermostat. But they also have a Cat5 cable going to our network, and that's for that independent management feature that each one of them has. They have built-in web not web browsers. They have built-in web servers in them, so they are able to serve up the interface directly without using any kind of a conventional computer server. All you have to do is point your browser to them anywhere on the network. So there are several different modes of operation, and we're going to get to this more sophisticated mode here in a second, but basically here's how they sit in the building, and then they also communicate to the outside world through our firewall and out into the world, both in terms of being able to program them, being able to get email notifications, text message notifications to your cell phone, and so on and so forth. So they're fairly sophisticated for the money, at least. All right, let's take a look and see how they are interfaced. If we take a look at the basic unit, there's not a whole lot to them, just like any other programmable thermostat. The thermostat cable is really pretty basic, and we won't go into that too much, but basically there's two stages of heat, heat 1 and heat 2, and there's two stages of cooling, cooling 1 and cooling 2, and that goes back to the controls for the furnaces, and like I say, it's beyond the scope of this particular video. And then there's also a fan line, and that is what we use for outside air. So the way to think of that is when the fan is on, we're circulating fresh air into the building. When the fan is off, we're not. And that is independent of these modes here. So you can have the fan on without the heat or cooling if we're in occupied mode, like we've discussed in a previous video. Naturally, if it goes into heat or cooling mode, the fan comes on itself, but that is not to be confused with having this particular line chosen, which is a switch inside of the thermostat, because that turns the fan on for recirculation, but it does not turn on the dampers that actually bring in outside air. So this is a little bit misleading, because it's not just a fan, but it's really the outside air damper that gets opened. So some people again call that, like we've talked in a previous video, occupied, but I think that gets to be a little confusing, because one of the modes, or one of the day classes in the thermostat, is called occupied, unfortunately. So that gets to be a bit confusing. And the way it interfaces into our network is just a little bit of a trick here, because we have to get through the firewall, and we have to be able to have a two-way communication going on that's secure. So let's first start with just the basic modes of operating them. There are four modes, well actually three modes, I guess. TDI, which is just a fancy phrase for thermostat device interface, and that's just using the actual touch screen itself. So if we look at this, going in and using the controls on there, they're fairly limited to what you can do, and it's going to be restricted further by the programming inside the unit. So that's the thermostat device interface, and we're not going to talk a whole lot about that because that's fairly self-explanatory. And this would just be, the interactive display itself. Okay. And then we have another mode called TMI, which is the thermostat management interface, and that's the web browser that you're able to go into and remotely administer within our building. That gives you all the features, all the capabilities, and is secured through two different passwords. There's an admin, which gives you everything, and then there's a user account that gives you, of course, fewer settings. So now, with that in mind, let's kind of look at how that interfaces into our network. Again, this is just a web server, so it actually has an IP address assigned to it, and it's a static IP. So we have 192.168.1.180, and this is a private IP range, and it's on port 80, which is the common port for HTTP, so serving up a web page. So if you can go to any computer within the building, as long as you're on this side of the firewall and type in that IP address, you don't have to do the port because that's the default, and you're going to get this thermostat. It's going to come up and ask you to log into it. We have actually set DNS. Let's see if I can print off the page here. We have actually set DNS on our server to give them a friendlier name. So for example, this one is the sanctuary. So if you just type in the word sanctuary, the DNS server on our church server will resolve that to the 192.168.1.180. Okay, and then like I said, this just brings up a web page, and you can click through it, and away you go. Okay, so let's take a look at some printouts of what the thermostat looks like and where these settings are made. We haven't exactly got a world-class video going here, so I'm not sure how well you can see this, but there is a tab on here called Network Settings. This is only available to the admin login, and this is how the thermostat communicates actually to the network. It has its own MAC address, but we have them configured for static IP, and this is just out of the user manual, so this is not accurate. Ours is .180 for the sanctuary. Subnet mask, the gateway, as a matter of fact, is correct for us, but that's our gateway to get out to the internet and to the wide area network. The inbound port, we're going to get to in a second. The web server is what we just talked about, so this is the HTTP port, and 80 is the default. So when you go to the 192.168.1.180, port 80 default, you're going to get this thermostat. It's just that simple. So moving along rapidly here, that's the TDI is the little LCD panel itself. The TMI is our local web interface, which is available this side of the firewall within the church building itself. Wireless or wired connections, it doesn't matter either way. Then we have the remote management, and this is where it gets a little confusing for some people, but really all this is just a server that communicates to the thermostats and then allows us to relay into it so that we don't have to expose our thermostats directly out to the world and then have two-way communication going on. That would be a pretty risky thing to do. So we actually communicate through the Proliphix server, and they provide a couple of different services for free and for charge, and there's also third-party packages available and so on, and that's really what makes this this whole solution really work. So if we go back here to our map, we're now going to deal with this router and how the Proliphix website is able to both read and write back to our thermostats. And then consequently, then you, anywhere in the world, can hook into their server, which then relays it through our firewall server and into the thermostats. Okay. So the way we do that is through a couple of different modes. One is called Remote Management Interface, and it's just a very basic interface that comes free with the thermostats. I think it's free for life. We haven't said anything otherwise. And I think this one's going to be phased out because it's pretty basic and it doesn't really give you much other than just access to the thermostats remotely. It's nice, but they're replacing it with this solution called UniVista, which allows you to group thermostats together, do all sorts of building energy management. You can have this kind of hierarchical thing here, which is pretty cool. And then most importantly to me is that you can keep graphs, you can keep historical records of all the settings and the actuals. So let's take a look and see how we communicate to this remote server from our local web server, our thermostats. So here's the thermostat, tstat, and again our local IP address here is 192.168.1.180 for the sanctuary, port 80. Okay, and that works pretty well for, within the network, but we can't have this IP address exposed to the outside world. For one thing, that's a private IP. But even if it were not, we would not want to have anybody in the world have a direct line, a DMZ right into our thermostats. That just wouldn't be a very good idea. So we want to go through our firewall. And more importantly, we want to go through network address translation so that we're only using our public IP, and then we're mapping it into here. Now the deal is we only have one public IP, and we have 5 thermostats, so we end up having to use some ports. And that's why we have to go through a couple of gymnastics here. But we need to get back to port 80, otherwise it won't work for local web browsers unless you have to type in a unique port number every time you use a session. So that wouldn't be very desirable. So what we do is we go through network address translation, which is on our firewall and our gateway, kind of the same box from Comcast in the wiring closet, and our external, I think I'm running out of the page already. Let's move this over a little bit. It's not a world-class video. And our outside IP address, let's just say it's 222.11.222.10 or something, because it changes all the time. And so we're going to map this to that through the gateway, and that's why we point also the thermostat points to the gateway to do that, and then it's going to translate our port 80 to port 8090 is the way it works out. Okay, so that's going to be inbound communication, so it goes like this. So if we want to talk to the thermostat, we'd go to this IP, it would route it through and end up here. The way it works out is we have 8090, 91, 92, 93. I'll go through that in a second for the different thermostats, and that gets routed to different IPs for different thermostats. Okay, now going the other directions, this is inbound. Now going the other direction, outbound, is actually a little simpler, and we just need to talk directly to their server. So the thermostat has a place to do that, and the IP address of their server, depending on which software we're using, there's different IPs for different servers out there, but 208.82.206.221, port 8080 is their server. And that just gets put directly in the thermostat, and outbound it goes. We just have to have, of course, our firewall allowing that traffic to go out, and we have to have this port here open on our public IP interface. Okay, so, and then, so this is the firewall. I guess the firewall is also here. And then the local traffic is still going on out here to our LAN, just using that regular old IP address that it uses, just as we talked a little bit ago. Now let's take a look at the printouts and see if we can see these or not. These are really bad. Showed you this IP address, which is its internal, the 192.168.1.180, the gateway, so it can find a firewall and the network address translation, and it's way out of the building. The port 80 here is the web server, the built-in web server for the LAN, and the inbound port is going to be this guy here. So it's actually 8090. This is just a printout from the book. 8090 is what we have in there for that inbound port. Then there's some additional fields here where you can have the LAN do auto discovery. You can put in a syslog and additional security if you want to be really hardened in terms of access. but we don't do that right now. Then there's another tab called Remote Access, and this is where you enable it first of all, and then you tell it the address of the server, of the host that we want. And this one is the 109, different one that I gave you here, but that's because this was for the remote access, whereas this one's for UniVista. So it just depends on which one you want. And then server port for us is 8080 again. Is what goes in there. And then it tells it how often do you want it to call the mothership. So like once an hour is reasonable, and then you can push this Discover Now button, and it just goes out and makes sure that it can find its way to the mothership and it communicates back. So it makes a round trip. And getting back is much more difficult because it has to go through this network address translation, and it's a much more hardened path, of course, than our network. And what comes up with another dialog here, and it just tells you that it did indeed make it, and it just confirms the MAC address of the thermostat and the port and so on, and the IP address of what it found. And it does that 24 hours a day, 7 days a week, whatever frequency you put in here, and that's how it keeps track of anything that goes down, and it can actually say, like I mentioned before, notify you if there's been an equipment failure. The customer ID is just so that it validates our subscription for the service out there. Okay, that's about it for the interface into the networks. And in terms of the software, we'll go through that in another video, but the remote access software is just a matter of logging into their website using a different set of credentials than what the thermostat. Again, the thermostat has an admin and a user. There's an I in there, an admin and a user logins, but that's completely independent of the remote access. That has its own software, its own login, its own credentials. That's all separate. Of course, we have to tell it what our admin is in order for it to be able to access the thermostat. So there's a little bit of coordination there behind the scenes. And each one of these, incidentally, is different for each thermostat, since each thermostat is completely independent of one another. Now, what's cool about these thermostats is that they really are a very flexible unit, and it's a startup company, so there's going to be new features coming out, new units. In fact, they now have touch screen little LCD panels that are pretty cool. There's going to be all sorts of different things coming out, and there's a fair amount of interest in terms of different ways to manage the thermostat from a software standpoint. So I think that's the exciting part. And it should be added that we actually have rights to the API, which is the application programming interface, which allows you to do anything you want with it. Basically the language that talks to the thermostat. And we got this is because, one, we could. It's more difficult to get now than it was then. We were able to negotiate that with them, and then we got it at no charge. It's about a several hundred-page book, and fairly rich command set to interrogate and to set the thermostat. Not that we want to go into the development business, but really our intent was to make it so that we have an interface that makes sense for a church, because that's pretty unique, and there's not a lot of software out there, at least at a reasonable price range, to let you tie something in like to the calendar whiz on our website, where we could just say, here's the time that we want to use the space, and then let it figure out the appropriate time to start it up, and then be able to actually improve itself so it can then measure its performance and so on. And we had budgeted at least from a tech team a couple $100, because that's really all it would take to write something like that. We wrote up a couple little prototypes, and it's like a scripting language, so it was pretty cool what we could do. That's still a possibility. The API is in the documentation, and it's just available right through a web browser, and it's built right into the units themselves. It's just a matter of the documentation. So that's pretty interesting. Then, just to give you an idea, here's another one of a company a couple of years ago. Probably have something newer by now, but this is just event automation software, and essentially it just is a way to automate all the different features in like a building management system, lighting, security, HVAC, and so on. And in this case, they offer the solution, but what's interesting is that they have partnered with Proliphix so that it's plug and play with their thermostats. So as you can see up here, I'll put this up there. the Proliphix thermostats are plug and play with it, and there's a variety of software like that available. In fact, here's another one. This is Event Management Systems, which is a different take on it, but this is room and resource scheduling, and they have different packages. In this case, they have one for a worship facility, and this might be a little bit big for us, but they have different sizes, different packages, and it allows you to go in and schedule your resources, rooms, calendar, the whole works. But when you're doing that, it automatically sets the thermostats because it's been pre-programmed. They've used that API to go into the Proliphix stats and so what this allows you to do is goes into this is a scheduling tool and finds the right room, the right resources, the right audio-visual, for example, and so on. Figures out how many people are going to be there or what have you, and then from that, it just does it. It goes ahead and reserves the room. It automatically programs the thermostat, and then if there's any change to it or anything of that nature, then it just automatically happens. So this is the really cool solution, and they have a variety of different packages from very small to large, so it's somewhat cost effective if we're looking at something, just to control blah, 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 blah. Who cares? Okay, moving along. Actually, we'll go to edit this. Okay, so now let's talk about, we're going to kind of jump around here a little bit. Let's talk about some of the advanced settings, because we're not going to go through all these thermostat settings in this session. But I do want to cover a couple of these that are going to relate to other topics in subsequent videos. There is a sensor page available to the admin, and okay, pretty bad, but there's a sensor page that interfaces into the temperature measurement. There is a built-in, of course, so it is able to tell the room temperature, but there also is the provision to have up to 2 remote sensors on each thermostat. So here's the local sensor, which is just built in, and normally, of course, you would enable it, and then you can have this sensor correction. If you drop this combo down, it's plus or minus, I believe, 5 degrees in half-degree increments. So if you, for some reason, have a unit that's off by a little bit and you want to calibrate it, you can set it to, be plus or minus the differential of whatever it needs to be accurate. Generally, that's just going to be at 0 because they're accurate as they stand. Then you can come in here in remote sensors, and these come in all different configurations. There's documentation on it. They can be just tiny little half-inch white screw-in pellets that go into the sheetrock that you can't even see, or little thermostat boxes that hang on the wall. We've actually got one on the west side of the building, a hardened outdoor thermostat that's in a steel box and has this kind of cone around it, so it keeps it from being affected by wind and sun, that measures the outdoor temperature. They also have probes that go into the ductwork, all sorts of different types of devices, and they're all like in the $20 to $25 to $50 price range. They're very reasonable, and they just wire into the thermostat. And in this case, you could say, let's say for example, we want to have a sensor out by the 31st Street entrance for the boiler. So we'd say a 31st Street entrance, and of course enable it, and then again you have sensor correction on that, and then what you would normally do is average. You'd say click this down and say enable, and then enable this one, and it would average these two and use that for the control point of the thermostat in terms of if it turns heat on or off. And then lastly, you can add another one. So if you want to add one over on the handicap entrance, you could certainly do that, and then average all 3 of them, for example. So that's a pretty slick feature. These also show up on the main page. Whatever you put in here is the wording it uses on the main page, and will actually say front lobby, and then like 26 degrees or what have you. So if you look at the office thermostat, you'll see right on there, both on the display of the unit itself and on the web interface, you'll see outdoor temperature, and that's that probe that's sitting outside that is ultimately going to be used for the boiler as a lockout mode for energy savings purposes, but we'll be going to that later. Okay, the advanced settings page, we're going to go through this quickly. The things that we're concerned about, this is right now set up for a heat pump, unfortunately, so it's not us, but the heat control is going to be either 1 or 2 stage, so we want 2H, which is going to be 2 stage. And then this is the second stage offset. So if you remember a previous video, I talked about a differential between stage 1 and stage 2. I believe ours are set to -4. Okay, I'm actually going to bring in our settings here, if you can see these, just because they're going to be more meaningful. We have a fuel burner, and then we have 2 stages, and our second stage is set to -4, which is actually a problem given the way the systems are configured, but normally that would be just great. The cooling control is also 2 stages, and that one in our case is +5. Really, it doesn't mean a whole lot. Typically, the first stage of cooling would be natural cooling, where you just bring in fresh air and try to cool the building as much as possible without turning on the actual compressor. And then the second stage would be turning the compressor on and of course driving up the energy bill, but providing a lot more cooling capacity. So that would be here the second stage. And if you have this heat pump, then you actually have an auxiliary heat source. We don't have that situation, so it's a little confusing here to look at this printout from the book. Hold mode duration is 1 hour, 2 hour, 3 hour, or 1 hour, 4 hours, 8 hours. That's when you override the stat manually at the stat itself or on the web interface, and you just say, I want to override it, and hit hold. That's how many hours it's going to hold it at that temperature before it reverts back to its setback schedule. So that's something that the admin person would set. Compressor delay for us is just 0 minutes, but that would be the amount of time, if we do have air conditioning, that it has to wait before turning the compressor on after going from stage 1 to stage 2, so you don't go too quick. And that's there's also a stage 2 delay. Fan on heat, we want to make sure that this is disabled, because that would go back to where we started this whole thing on that fan line, which is our occupy, which opens up the outside air dampers. This is saying that whenever we have heat, then we want to open up that outside damper, and we certainly don't want to do that. So that's again a little misleading, because certainly we want the fan on when the heat comes on, but the furnace does that all on its own. So the thermostat doesn't need to turn the fan on for heat. And in fact, this would be, again, to belabor the point, this would be opening up the outside air on heat. We don't want that. Set point differential confuses people for some reason, but it's really pretty simple. It's just saying we don't want the thing to be nervous. So if we have the room temperature set for, let's say, 70 degrees, we don't want to get to 69.9 and then turn the heat on, and then at 70 turn it off, and at 69.9 turn it on. We want to have a little bit of play there. So the set point differential is actually split in half. So it's going to go half above, half below. So that means 69 to 71. So it's going to wait till it drops down to 69.0, and then I'll turn the heat on until it hits 71.0. So it's going to play back and forth. And 2 degrees is typically considered, I think, by most engineers, a good setting, and that's what was recommended to us. But that certainly can be changed. Maximum cool and maximum heat cycles per hour. Probably not terribly applicable, although we have used that for the... So we're going to bounce around here a little bit more. The intent here is just to kind of give you a flavor of what's going on. The thermostats are very well documented, and you can certainly ask me or read about them. There's user forums on Yahoo. They work well, so they're not buggy or anything of that nature, so there's probably not a big reason to go through them in great detail. But just a couple more things that are interesting. On the main page of the thermostat, you're going to see that there's actually a low temperature, high temperature filter change settings where you can say if it goes below, for example, maybe like 50, you want to be alerted, or if it goes above 75 or what have you, you want to be alerted. And then the filter change is based on days of usage, not just elapsed days, but actual days of the fan blowing air through it. If they're set right here in the thermostat itself, then really all they do is just alert the little LCD screen. They pop up with a little alert that says that, let's see here, basically there's a little alarm that comes up and says that it's time to change the filter or take 2. These are the most basic alarms. If you set them right in the thermostat itself, then it's just going to put up a little alarm icon and say that there was a low temp alert, and you can clear it then with the push buttons, or a high temp little icon. So you can check them. It's not going to do anything much more than that, so it's fairly innocuous. Where it becomes more powerful is when you hook it into the remote software. If you bring up the web page, of course, it's just going to say here in red that it hit this particular temperature and tell you when it did that, and then you can hit the clear button to clear it once you've logged in. So you don't have to log in at all, by the way, just to see what the settings are, to see this page here. But if you go to the remote, and let's take a look here at the most basic, the remote access software. And when you go to set it up, you give it your customer ID and all this kind of stuff. And then you set up notification email accounts down here, / mobile phones. And you can just put in either your email address, of course, or you can put an SMS in for your cell phone and have it text message you when there is an alert that has been set. So it's either going to be the high temp, the low temp, the filter needs changing, or it can't reach it because it didn't call home within that 1 hour discovery period where it needs to call home to the mothership each time. If it didn't do that, then it tells you that it can't be reached. If for some reason the server goes down, it'll also tell you that it's been firewalled, saying that it has one-way communication, but something has gone wrong with our firewall, and that, of course, can happen from time to time when we're doing something with our server. So that works pretty well. With the more sophisticated software, you're actually able to go in and set more exacting criteria that it digests and then sends out messages to you. But it works real well, especially with the cell phone, because you get alerted right away if there's a problem, and then you can deal with it generally remotely. Okay, and lastly, I developed a few forms here that are in the handoff documents. This one here is in the furnace documentation, the big binders, but this just goes through all the different fields that are in the thermostat and documents how we have them programmed. So the thermostat setup, the name, the serial number, the remote sensor, like we talked about, remote sensor 1, remote sensor 2. You can put contact information right in there so that if someone has problems, it comes right up on the display. Here's the setback schedule, the alarms that we want to enable. So if you want to have like the filter runtime could be enabled, and you could say I want to do it every 60 runtime days. There's actually a fail-safe temperature that is not shown anywhere in the interfaces. It's actually in the hardware itself of the unit, and it can be changed. But it says that if all else fails, if the programming fails, if the server fails, if everything fails, if it hits a certain temperature, it will turn the furnace just on and let it run. And that can be set between 39 and 52, and I believe we're set like at 45 as a default or something. But that's like done right inside the unit itself with little jumpers, and it doesn't rely on any hardware or any software at all, so it's a very reliable fail-safe to keep us from freezing up. Let's see if we can even see this. The preferences, just about the display is going to look, the 2 different logins, the overrides. We didn't really go through that, but it's fairly self-explanatory in terms of how to program if people can override and how much they're allowed to override, the IP, and inbound and outbound for the network. We talked about that. And then the advanced setup here as well. So this is a pretty handy worksheet to document everything, and highly recommend that we, as we make changes, probably not with the setback, but with anything else, that we keep a new one of these sheets and then keep the old ones as well, so we kind of have a history of what we've done and what we are currently doing. I also developed another form because at the beginning of this whole thing, it's very subjective in terms of what's warm, what's cool, and so on. We really can't just use I feel warm or I feel cold, and temperature is one of the criteria, but there's certainly a lot more going on here, particularly with a congregation, because you have people of different ages, you have people wearing different levels of clothing, people who are just sitting still, people who are singing, all different types of subjective types of things are going on. So I've listed a few of them down here. The objective measurements, just to keep this fairly simple, are room temperature, the building temperature, and that would be like the floor, the pews, the actual structure itself, the room humidity, and then wind chill, or just the sensation of moving air, because there is going to be moving air with the occupied mode being on. The subjective measurements are warm, cold, drafty, things like that. So this is a survey that we put out to a number of people, and I think it's still a good idea when we have complaints that we quantify it with something, at least resembling science. Put their name, date, where you were seated, and then we really wanted them to keep track of the time, how they felt, where it was coming from, what they were doing, and then this last column is the correlations. You can see it, there we go, was something that we would do, because on the days that we were doing the survey, we would run the graphs in terms of how the furnaces were programmed and how they actually operated. So we'd be able to see the temperature, the amount of air movement, and then look to see what actually happened, and then based on a timeline, and then see if we can find some correlation here. And the correlation was really quite remarkable at the time, that people were really sensitive to just moving air, and particularly sensitive to building pressure. If we pressurized a building by bringing in outside air, more outside air than what we let out, it actually keeps it from becoming drafty. In an old building, particularly people coming and going in the middle of winter, that draft can actually make someone feel colder than the air temperature would lead you to believe, especially if they're just sitting there. So by pressurizing that, we found that people, even sitting over by the windows, were really quite comfortable. Okay, we have one more, and this one is not mine. This one's actually from the state of Minnesota, and I feel somewhat strong about this one because I think it's an old building, and especially downstairs, there's no windows that open. The restrooms have no ventilation. They don't have any opening windows. We have a kitchen. We have Sunday school kids. We have meetings every night of the week. We have people coming and going of all walks and lives, and stale air. So I think getting some type of air exchange going makes sense. In the main sanctuary is probably kind of silly almost, because it's just one big box, of course, but it still applies, at least in terms of Minnesota code, that we have to comply with that. But this is the Indoor Environmental Quality Survey, and I would still recommend that we do conduct this survey with some select people, which we have done, particularly people who are here a lot, and just go through and see, on the long term, what it is that they're experiencing. Are they too warm, too cold? Is it dusty, humid? Things like that. And then, are they able to, if we were doing painting or something, has that been a problem? Moisture buildup, all those kinds of things. It's really a very good survey. And then it continues on back here and talks about symptoms and so on. And it's amazing how the indoor air quality can actually affect your productivity and headaches and things of that nature. So this goes along with a pretty decent set of documentation. They have this booklet here, Building Air Quality, a guide for building owners, and this goes through talks about the importance of doing monthly inspections or at least quarterly inspections and making sure that your building management system is properly programmed, all this kind of stuff. And it's really quite remarkable, on track with what we need, because it talks about design development, what we went through in terms of making sure that the system performs the way it needs to. The working drawings, which we did not do. That's the area that we just completely blew it, and is the source of, in my opinion, the majority of our problems. And talks about the construction work and so on. Actually, pretty well written, concise, and it's from the Department of Admin. And then they have a more extensive booklet here, which is really their internal book for building managers within the state of Minnesota. So this is probably a little overkill, because it goes through and talks about how to come up with a management system and a plan, and measuring carbon dioxide levels and all this kind of stuff. So this is certainly overkill, but there is a couple of sections in here that actually explain nicely how the ventilation system works. So in about a page and a half here, they go through the outdoor air intake, the exhaust air outlet, all the types of things that we need to be aware of, and how to do the filters, the recommendations for that, and so on. So it's a nice reference piece, but certainly targeted toward a much, much larger organization than ours. Okay, and we just have a couple more here items to finish up on. I mentioned that we have 5 thermostats, and 4 of them are NT120s, and 1 of them is an NT130. The only difference is that the 130 came out a little bit later than the 120, so it had a new feature that we thought would be particularly useful for the office area, the boiler system, and that's that it has an OBO feature, which is a 1-button override. So instead of having, let's say you come in on the weekend or in the evening or something, instead of turning the temperature up, by so many degrees, you just push the 1 button and it changes it from unoccupied to occupied in terms of the setback schedule, and brings it up to room temperature for whatever duration you have the hold mode set to, like 1 hour, 3 hour, 4 hours, so on. So that's a pretty nice feature, and then when you're done, you can just hit the button again and it goes right back to where it was. So you don't have to fiddle around moving the temperature up and down. It's really good for building energy management. Okay, the API, as I mentioned earlier, I actually have a copy of that now, and I was exaggerating dramatically. It's not hundreds of pages, it's only a mere 35 pages or so. So it's pretty basic, and not that we're probably ever going to use it, but here it is. Just uses PHP, and it's, like I say, built into the system, built into the thermostats, and this is just the documentation of how to get at it, and would allow us to write our own interface. I think the church is unique, and this is something that when we get into the construction part of the furnace project, we'll talk a little bit more about it, but a church is unique in that it's primarily going to be run by volunteers that are multi-generational kind of hand-me-downs, so it's like one goes to another, which leads to another. So we don't really have really good continuity of information. It's going to be largely verbal. Who knows, how that information is going to be passed down. So it's really important that the system be well documented, well labeled, and fairly easy to understand. So that's an important component of it, because staff realistically, is not going to get that involved probably, at least until we get to be a bigger program church. The other thing that's unique about a church is that out of 168 hours a week, we only operate 2 hours of the main space, the sanctuary. So the setback and the fresh air exchange and the minimum outside air, all those types of things are really big deals. They're normally a big deal, but for us, 166 hours is not used essentially, although it may not be that much all the time. But that allows us to really do a tremendous setback, and we have information coming up too about how far to set it back and what's realistic, and kind of getting into some old wives' tales there, and also to minimize the air exchange when it's simply not needed. So that's why I really harped on those features so much. The other thing is the schedule. In other areas of the building, it is very dynamic. So you'll notice that we have a lot of zones. We have the 5 thermostats, and it's because we have different areas of the building being used while adjacent areas are not being used at all, and that schedule changes literally every day. So that's why the internet Proliphix thermostats are nice. The downside is that the software that comes with them is pretty basic, and really is similar to like a home or an office where you have an occupied, unoccupied, and then an exception. So you have like 3 different schedules to choose from, and that's doesn't really let you schedule exceptions out more than just a couple of days at most. And whereas you can go out for 2 years in the calendar. So that's why we really want to look at some other software, particularly this API where we just write our own stuff, because in fact there's other churches who are having the same dilemma, and would probably be willing at this point, since they've been using the Proliphix for a couple of years now, be willing to share with us, or vice versa. Another document that I created is a card, and this is just a hard copy printout of it right now. But this is a double-sided card that just is a handy and concise guide to the heating system, and just goes through and talks about each of the different zones, different furnaces, the IP addresses, how to get to them. On the back side is kind of a living document. I was hoping this is going to change and live as time goes forward, but just fundamentals talking about how this best managed in terms of the thermostats and the setback schedule and policy and so on, or procedure, excuse me, and then some recommendations. But we really stop short of policy. This is really supposed to be best practices and procedures, and then we leave the policy up to staff. So everybody on staff and key volunteers should have one of these, and that should again live with the system, and the best practices and so on should be updated so that we're learning from each other as time goes forward.